Hello friends, welcome to TEQIP GATE classes. My name is Professor Vivek Singh Rathore and I am Assistant Professor in Government Engineering College Bilaspur in Electronics and Telecommunication Department. In this video lecture, I am teaching Signals and Systems subject, and this is the sixth lecture of this series. So earlier we have seen many type of elementary signals and basic operations on these signal, and in the last lecture we have started classifications of signal, and in this we have studied real valued signal and complex valued signal, and our continuous time signal and discrete time signal. Now from this lecture, in this lecture I will be dealing with another type of classification, another classification of signal, that is even and odd signal. So let's get started. See, okay, I will start with here. I think I'll write here even and odd signals. Okay, so see, from childhood we have studied what is even numbers, what is odd numbers, but here we are studying what is even signals and what is odd signals. So see, there is a criteria for justifying that it is an even signal or odd signal, or we can detect it is an even or odd. So see, a signal I am taking, this one signal, and this signal is like this. Okay, let's suppose this value is -1 to 1 and the magnitude is 1. This signal is has been asked that it is an even signal or odd signal. So the first criteria which we should know for detecting it is an even or odd is that if you are taking a signal ft, okay, and if it is equal to f of minus t. F of minus t you can understand because we have already studied time reversal. Okay, so if ft is equal to f of minus t, you can definitely call it as a even signal. Simple concept. Okay, and if your signal ft is equal to minus of f of minus t, then f of minus t is time reversal and this is magnitude reversal. So even this condition satisfied odd signal. So this two condition you should remember. But if your signal is neither equal to f of minus t or neither equal to minus f of minus t, then see, either it will satisfy this condition, either satisfy this condition, either it won't be equal to f of minus t and minus of minus f minus t. So this condition, if your signal is like this, then it is neither even nor odd. So this three conditions you should remember for seeing a signal is even or odd. Okay, so let's see. And first of all I will tell you, see, every signal in nature, every signal will consist of both part. Okay, it won't consist definitely both part, but generally a signal have both FET and FOT, where FET is even part and FOT is odd part. Means a signal has some even part, some odd part. Okay, so whenever you need to see, in even signal, obviously odd part will be absolutely equal to 0. Okay, so ft will be equal to fet and the condition will be even signal part. And if your signal is only odd part, only odd signal, okay, so for that case even part will be absolutely 0. So only the signal will be having odd part, odd component only. Okay, and the condition for calculating means if a signal is given to you and you have been asked that calculate its even part and odd part, so how we can do it? So for even part, for even part of any signal, you just need to add ft plus f of minus t by 2. Okay, and for odd part of any signal you need to do ft minus f of minus t by 2. This formula, this basic concept you should remember for even and odd signal. Only I have told you, if ft is equal to f of minus t, the signal is even. F of t is equal to minus of f of minus t, that is odd signal, and both condition doesn't satisfy, that is neither even nor odd. Every signal consists of even and odd component. If you need to calculate even component, you just need to add ft plus f of minus t by 2, and if you need odd component, you need you have to do ft minus of f minus t by 2, just this much. Now let's check for some signals, either they are even or odd. So I have already taken one signal. So this signal is there, okay, and it ranges from, let's suppose, -1 to 1, and magnitude is 1. This is ft. Now I have told you the condition. First check it, f of minus t, okay. So if you do time reversal, so just it will be rotated across y-axis. So this will be like this only, and here again it will come like this only. So you can see f of t equal to f of minus t. So this signal is called as even signal. And see, we'll take another example. Let's suppose like this signal is there, okay, and this signal is there, okay. This signal is there, and this is ft, and this is -1 1, and this is I think sorry, this is -1, and this is -1. So now let's take f of minus t. So what we can do, we need to just do time reversal. So this will come like this, and this will come, I think, like this, okay. So this will be +1 only, this will be -1 only, this will be 1, and this will be -1. But you can see this both is not equal. So this is definitely not even signal. So let's try minus f of minus t. So just magnitude reversal will do it. So we'll do it like this. Magnitude reversal means this will come in downward, and this will come in upside, okay. So this will be like this, and this will be like this. So this will be +1 only, this is -1 only, and 1, and this is -1. You can see that these both signal f of t and minus of f of minus t are equal. So definitely you can say that this is odd signal. So see, generally odd signals are also called as anti-symmetric signal, because it doesn't satisfy symmetric property, na. That's why it is called as anti-symmetric property, anti-symmetric signal. And whenever we say even signal, we always say it is a symmetric signal, okay. It is a symmetric signal. And let's see one more example. We'll take it like this, okay. Some value is there, -1 to 4, and the amplitude is 1. Now this is your ft, okay. Now you need to plot. Let's suppose we'll plot f of minus t. What we'll do, we'll do like this, and this will be time reversal. So it will be here 1, and this sorry, I think this will go like this, okay. So this will be 1, and here it will come -4, and amplitude will remain same. But see, you cannot say both are equal, so it is not equal to 0. Both are not equal. So let's plot f minus f of minus t. So when we will do like this, it will come f of minus f of minus t, means it will come downside, okay. So it will be like this, 1 and -4. See, both signal also you cannot say that this is equal. So this signal which we have plotted, this one, this is neither even nor odd, okay. Neither even signal nor odd signal. It is it can be said as non-symmetric signal. So I have told you both all symmetric signal, anti-symmetric signal, and non-symmetric signal. So these are all the conditions. See, one more thing I want to tell you. Whenever we add actually f of t and f of minus t, you know, f of t and when equal to f of minus t, it will be even signal only. So whenever we add these both signal, we will get always even in nature, okay. Let's see one signal we have seen, okay. this signal we have seen -1 to 4. This signal is neither even nor odd, means it contains some even part and some odd part, that we can know. So let's see if it is ft, and if let's plot f of -t, then you will get I think from here to here 1 and -4. This is ft and this is f minus t. If we add both, then what we will get? We will get C. From -4 the signal started, so -4 will start the signal, and at -1 again it is amplitude is 1 only, it is there is step change, so we'll again do at -1. Okay, -4 -1, and then it will go on. At 1 there is step change of 1, so at 1 will tell as step change, and at t is equal to 4 there is a step change again. So see, this signal is f of t plus f of -t, and this signal, if you see it, you will get it that it is an even signal. See, one shortcut or one conclusion I will tell you: whenever a signal is symmetric across y-axis, you can definitely say it as even signal, and whenever a signal is symmetric about our first quadrant and third quadrant, then this signal can be called as odd signal. This is just a conclusion after seeing so many signals. So here also we can prove that this signal was neither even nor odd, but we know that whenever a signal ft, when it is added with f of -t, then it definitely, whatever the output will come, that is always even in nature. So this can be asked in some objective type of questions, and whenever we do, f of t minus f of -t will always get a odd in nature signal. Okay, if you want to try, you can try also. Here f of t was there, okay, -1 to 4, and this was 1 and -4. This of f of -t, if you want to see minus f of -t, we can plot it like this. Okay, 1 and -4, and this value is 1 -4. So you can add it ft and plus this one signal, you will get this. So we'll do it. Okay, see, from -4 the value is step change downside, it is going on, and suddenly at -1 there is a step change at this, so it will be -4 -1, and it will go on like this only. At 1 again there is a I think at -4, and it goes on, and then again it is like this only. And okay, so I think this was a mistake. So it goes on like this only at t is equal to 1. Okay, t is equal to 1. At t is equal to 1 there is a step change above, so we'll do it step change above, and then at t is equal to 4 it is step change downside, so it will be step change at downside this. So you can see it, this signal, first quadrant and third quadrant are similar in nature, so this signal will be odd in nature. So this you can conclude it, and there only we have seen the t will be equal to even part component plus odd component, and even and odd component also I told you how to calculate it. So let's see some other examples. Like if you see cosine signal, you know cosine signal, cos t, if you do cos of -t, you'll get it as cos of t only. See, these both are same, f of t and f of -t, then this signal will be even in nature only. So you can plot it like this also. Cos t is like this, and this is also like this. Okay, I think this is like this. So you can see both quadrant, first and second quadrant, are similar in nature. This signal is called as even signal. If you plot like this, some signal is there, e to the power -a mod t. So this signal is also similar in nature. You can do mathematically also, you can do it. So this will be also even in nature. But let's see some signal like sine signal is there. Sine signal is and like this, it's there. So sine of t and sine of minus t, you'll get minus of sine t, and minus f of minus t, if you do, it will come again sine t. So this both are equal, so this signal is sine t is odd signal. If you see signum, so this is our odd signal. Okay, signum t. So both are quadrant are same, so it is a odd signal. But if you calculate for unit step, okay, unit step signal, what will get, you see unit step signal is unit step ut is there. Okay, and ut can be represented as 1 for t is greater than 0 and 0 for t is less than 0. Ut is like this. But whenever you will do u of minus t, you will get as this signal. Okay, but these are both are not equal, so let's do minus u of minus t. So minus u of minus t, you will get like this. Okay, so again these both are not equal, so that means ut, unit step signal, is neither even or neither odd. It is not even nor odd. So what we can do, so I have already told you, every signal consists of some even part and some odd part. You need to calculate even and odd part. So for even part, you need to do f of t plus of f of minus t, means ut plus u of minus t by 2. So whenever you do u of t is like this, u of minus t is like this, and the magnitude is half, so we'll do half. Okay, signal. So can you say it as a DC signal, and the value will be only half only. Okay, so u et will be half value. Okay, and uot, okay, uot, that is odd part. For odd part, what you need to do, u of t minus u of minus t by 2. If you want to plot it, you can plot it. See, u of t is like this, u of minus t is this one, and negative portion will be this one. So and the magnitude is half. Okay, so what we can plot it, this is the signum function. So u of ot will be signum of t with the amplitude half. So now if you say u of t will be equal to u of et plus u of ot, then it can be half plus half of signum t. This can be represented as ut. So this expression is also very important. Many times this expression has been asked in engineering service exam, GATE exam. So this expression, now you can understand that how this expression comes, because it is a component of even and odd part. So we have calculated it like this. Now we can see some of the property for even and odd signal. Like, see, whenever a odd signal, okay, whenever a odd signal is multiplied with odd signal, what happens? Okay, so you can do it, you can multiply with signum t and sine t, or you can do sine t into sine t, so you will get cos square t. So sine t into sine t, sine square t, and that will be mathematically we can write cos 2t. So somewhere we'll get it as, like, see, signum t into sine t is there. Whenever this signal is, let's suppose ft is there. Now if you take f of minus t, what you will get, signum of minus t into sine of minus t, you will get it as signum of minus t. When you will do, see, signum of t is like this, and signum of minus t will be like this. Okay, so it is just a signum t, it will be, and sine of minus t will be equal to minus of sine t. Okay, and signum of minus t will be like this. And whenever you do minus signum of t, what you will get, see, this was signum t, you will do minus of signum t, means magnitude reversal, so it will come like this, and this will come like this. So you can see minus of signum t is equal to signum of minus t, है ना? So you can write it as minus signum of t, and sine of minus t will be equal to minus of sine t. So it will be equal to minus into minus plus, so you will get again signum t into sine t. So what you can conclude is f of t will be equal to f of minus t. It means the output of this signal will come as even. So odd signal when multiplied with odd signal, you will get always as even signal. So this should not be remembered. This you can do it if you are having confusion, otherwise it is simple. If it's the same thing, you can calculate for even into even also, you will get even signal only. You can take any example and you can justify or verify it. Okay. And whenever you will take odd into even, okay, odd or into even, like sin t into cos t, if you will take and just do mathematical expression, you will come to know it will come as odd signal only. So you can treat it as plus into whenever you do plus into plus, you will get plus. Okay, plus into minus, you will get minus. Minus into minus, you will get plus. Like this is there. So minus you can take it as odd and plus it as even, and you can calculate it. So this was there. And for differentiation, whenever we differentiate a signal, like this signal is there. Okay, this signal is there, minus 1 to 1, and whenever we differentiate it, okay, what we will get, see, it is a slope. What is the slope value? Slope is 1 minus 0 by 0 minus minus 1, है ना? So it will come 1. So slope is plus 1, and here its slope is minus 1. So you can say, I told you earlier also that whenever ramp signal is differentiated, it will come as step signal, and step value will be same as change in slope. So this is the value. This is the value of step. There is a plus slope, so there is a plus step change, and value will be 1. There is a at t is equal to 0 only, there is a step change. So this will be their step change, and then again at this point there is a step change. So we'll do it like this and this. So this signal, I think this is first and second. So this signal will be, I think, odd signal. So whenever you do differentiation of even signal, whenever you do differentiation of even signal, you will always get odd signal. And whenever you do differentiation with odd signal, d by dt of odd signal, you will always get even signal. This all are some property of even and odd signal. Now only less thing is left. We have already seen some real valued signals, and we have seen how to do how to check even and odd part. There are complex valued signal also in continuous time domain. So for a complex valued signal, let's suppose we are taking some example of e to the power jt. This is a best complex valued signal for example. So this is actually called as cos t plus j sin of t, e to the power jt, that is called as Euler signal. So for complex valued signal is also the almost same condition. See, f of t, when it will be equal to f of minus t, this signal was even signal. But in complex valued, if f of t is equal to conjugate of f of minus t, then it will be a even conjugate signal. Okay, even conjugate signal, or it can be called as conjugate symmetric signal. If the signal f of t will be equal to minus f of conjugate of f minus t, then it will be called as odd conjugate signal or conjugate symmetric signal. Okay, so you can remember it as odd conjugate signal or conjugate antisymmetric signal. So we were about to see this signal e to the power jt is conjugate symmetric or conjugate antisymmetric. So e to the power jt, whenever this is ft. Now whenever we want to do f of minus t, what we can do, e to the power minus j of t. And if we are doing conjugate symmetric, so wherever j part is there, we will do negative sign opposite. So earlier it was negative, so we will do it positive. So you can see f of t is equal to f of minus t, conjugate of f of minus t, then e to the power jt will be our conjugate symmetric signal. Okay, conjugate symmetric signal, this is the conjugate symmetric signal. But whenever we let's see one signal f of t is equal to t into e to the power jt, this signal is there. Okay, Now if you want to do f of minus t, what we can do, minus t into e to the power minus j into t. Wherever t was there, it is replaced by f of minus t. If we see conjugate of f of minus t, will do it, minus t will remain same, e to the power wherever j is there will do reversal, so it will be plus jt. So can you say that f of t is equal to f of abstract f of conjugate minus t? It is not there. But whenever we see f of conjugate f of minus t, we will get see minus sign will be there, so t into e to the power jt. So this portion is equal, both are same, so this signal can be called as odd conjugate signal or conjugate antisymmetric signal. Okay, and for conjugate antisymmetry, this conjugate signals also means complex signal also. See, every signal will have, if it is a complex valued signal, it will have both component, even conjugate part also and odd conjugate part also. Okay, odd conjugate part also, like a signal consists of even part and odd part, same as even conjugate part also, odd conjugate part also. So for calculating even conjugate part, what you need to do, you need to do f of t plus f of conjugate of minus t, okay, by 2. And same as odd conjugate part, you can do f of t uh, minus f of minus t conjugate, okay, by 2. So almost the same thing is there which we have studied in real valued signal also, and you can calculate it very easily. It is very easy for calculating it. Okay, so this was the portion which we have seen in this, and you can see it for discrete time signal also, because discrete time signal also the signal will be f of n only. Okay, so what we need to do, f of n equal to f of minus n, then it will be even signal. F of n when equal to minus f of minus n, then it will be odd signal. And when both are not satisfying, it is neither even nor odd part. Okay, and same with our even conjugate part also. So in complex valued signal, for discrete time signal also we can calculate. So this was the thing which I wanted to tell you for even and odd part. I think you after this lecture you must be confident for solving even and odd signal. Next lecture will deal with some other classification, like what are periodic signal and aperiodic signal. So till then, okay, tata, bye bye, see you, have a good day.